Okay. So good evening, everyone. Welcome to the live session of this course, Multi-Core Computer Architecture, Storage and Interconnects. We are approaching to the fag end of a course, another few more weeks that is been left. So close to 9 weeks have successfully gone well. And then happy to see that students are picking up the assignments also very well. So the question paper, everything is being transferred, and then I have tried to see that almost if you have seriously taken the assignments and assignment questions, well, the solutions of the assignments are also detailed posted. So that will be good enough to get 60% of mark. And today's session, we will be very happy to take up if at all you have any specific queries. So request you to, yes.
Sir,
please introduce yourself first. From where are you, and then start the question.
Okay. Hello, sir. My name is Akshit Kapoor. I am from SM Video, Katra. And my question is, sir, for reference purpose, only Hennessy book is enough, na?
Yeah, up to network on chip, that processor and cache memory, Hennessy and Patterson book is enough. That's good enough. So network on chip, it's principles and practices of interconnection network. The last 3 weeks is network on chip. So principles and practices of interconnection network is required for that.
Okay.
So if you go through the videos and then go through the tutorials at the end of this week and getting familiarity with the assignment questions, that will take care of most of the thing. But if you want a deeper understanding, then read the textbooks.
Sir, what about above the 3 weeks? Like it covers network concept. What about other?
Which one? Can you repeat the question once again?
Sir, as per you said that Hennessy book is enough for last 3 weeks.
No, it's not enough for last 3 weeks. Up to first 9 weeks, it's okay. The last 3 weeks, we have to go for principles and practices of interconnection network. That slide is there in the introductory video, which talks about the textbooks.
Okay, sir. Thank you, sir.
For all related to processors, GPUs and cache memory, Hennessy and Patterson is okay. Okay, so we have a question from Shobit. Do GPUs, this is there in the chat box, so others can also see, do GPUs also have ISA similar to CPUs? Are the ISA similar to the one that we have for CPU? Can we program NVIDIA GPUs in assembly for the sake of appreciating inner architecture of GPUs? No. So there is nothing like instruction set architecture specific to GPU. GPU only have very simple set of instructions. It's about loading data into the memory and then executing the kernel. So it doesn't support a wide range of instruction. It's only about triggering the internal thread. Okay. So we have certain specific commands that we call. It is not like an instruction. It's a specific set of commands that is being run by the kernel of the GPU. Before executing the command, the appropriate data has to be loaded into the memory associated with the thread, the block, and the grid. And then it will do the task. So since I already mentioned, GPU is a single instruction, multiple data stream format. So one instruction that is being, so we call it as one command, and all the streaming multiprocessors and the corresponding thread processors that is there inside will execute the task associated with the data that they have. So it is very unfair to have programming comparison between CPU and GPU. It's like comparison of apples and oranges. CPU is used for a wide range of instructions on a different range of data. So instructions can be from simple instructions to complex instructions, whereas GPU only supports simple instructions, but that has been done on a large pool of data. So that's a different. So when you come to the second part of your question, can we program NVIDIA GPUs in assembly for the sake of appreciating inner architecture? No. We have to use CUDA architecture to translate certain CPU instructions into its corresponding GPU equivalents, such that the task can be done on GPU in a more efficient way wherever data level parallelism is there. So Shobit, I hope you understood your query.
Yes, sir, it is clear. Thank you.
Okay. So Chirag, can you speak about what is the question. I have seen something there, lecture 31. But I
So,
am
sir,
not, yeah.
so in lecture 31, I think we multiplied 2 power 20 and 8 bytes. And so like it should have been 2 power 23. So did I miss something or it's a miscalculation? I just wanted to clarify that.
Lecture 31 is on cache coherence.
Yeah, I think.
Let me take the slide first. Okay. So I will come back to your query once I take the slide. But in the meantime, if someone else has any other query, they can post. It would have been better, no, since you post these queries in the forms early. If it is specific to any lecture, I could have gone to it and then keep the answer ready.
Sir, the sheet was like view only mode. It was not like editor access. So
Yeah, sir.
I
Yeah.
actually
Then you could have brought it to our attention in the discussion forum.
uh,
It was red, sir, actually.
So where are we talking about power? In which slide? Is it at lecture 4J?
I had added one image in the chat. I mean, I don't know if it is lecture 4J or not.
it is 4K, sir. It's 4K.
Yeah. So what is the
4.
query that you have?
I just wanted to clarify the calculation in that part.
Which
It was
calculation you have doubt?
it's a question about computer uses memory question. Data storage per node 200 MB, 25 star 8 star 20 power 2 power 20, and then it becomes 2 power 26. So like, is that
No, I am not able to understand your question. What is the doubt inside that?
sir? Directory storage per node, the calculation.
Sir will join soon.
Yeah. Sorry, there was a glitch in the network. So can you tell me what was the question once again? Can you put up in the chat box? So once again, what was the query and then put the picture. Since I rejoined, I missed the previous chat. Okay. Yeah. Now I can see. The question is, shouldn't be power 2 power 20 into 8 byte be equal to 2 power 20. So what was your question? Can you tell me once again? Is it not 24 MB or something else?
Sir, I thought it was a calculation mistake, or it should have been 2 power 23 since it's 8 bytes. 8 bytes, like it would be 2 power 3 and then it would be 2 power 23, but in slide it's 2 power 26.
I think we need to convert the bytes to bits, right? So that's where we need to have the extra 3.
So it is like 8 MB into, 8 into 3, 24. This byte into conversion, since I am not able to get what your doubt is. Is 24 wrong, or you are just showing a screenshot? So in the screenshot, I am not able to see anything. Can you be more elaborate on the doubt that you have?
I'll share a screenshot just until you can carry on.
Yeah. See, so there in the slide, we don't have anything, but maybe in the class, there is something. So if you tell exactly, or else I have to go through the video exactly at the point. I didn't get the doubt. So if you can be more precise, it would be helpful. Okay.
I'll share a screenshot.
Yeah. Okay. So in the meantime, if someone else has a query, please let us know.
Hello, sir.
Yeah.
Sir, I'm Sudipta from Royal Global University.
Okay. Yeah, Sudipta.
Sir, how are you?
Yeah, good. Fine. Thank you.
Sir, I have like 4 questions, like a very simple questions I have jotted down. Sir, can I ask them sequentially?
Yeah. You ask one by one, then I'll tell the answer and then I'll get back to the next one.
Thank you, sir. Sir, I just have a question. Like, sir, is the cache memory volatile or non-volatile?
Cache memory is volatile. It's just like main memory. It's volatile because it's built using transistors.
Oh, that means, sir, every time we close the computer, everything there it gets erased, right?
Yes. Just like main memory.
Okay. Sir, now second question, sir. But sir, I was noticing one thing, like when I was writing in a MS Word, sir, I noticed that until we saved, sir, everything it runs in the RAM, right, sir? We open the Word file and everything we write, everything we do until we save it in the secondary memory, it stays in the RAM, right?
RAM only. Yes, correct.
Yeah. So, sir, what about that undo and redo button that we have? Sir, that thing also goes into the cache memory, or it has its own data structures
No, it
in
is still going into the cache memory, and within the cache memory, there are some spaces in which stack and heap is being implemented. So when you do undo operation, it is actually saved in some block of cache, and then you are making the update that is being required.
Okay.
So this is all that extra utility spaces that is being given on an application, which ultimately in memory is some heap location where you temporarily store the data. So there is a point by which my undo will not work. So there is only some limit of data which I can do, which we call it as checkpoints. So from one checkpoint to another, it can be undone. Beyond that, it's not possible.
Okay, sir, I got it. Sir, actually, this can also be implemented with the help of data structures, right? In a software-based environment.
See, whatever you do in data structures, ultimately it has to take care of your memory side, right? You have to do it on some memory. And that is where whatever you do in data structure, it's an abstraction that you do.
Okay. Yeah. Sir, the third question I have. Sir, OS is also OS. Sir, what is the OS? The OS is like the interface between the hardware and user, right? It's like the basic need to have a interaction with the hardware. So it is also stored in the hard drive of the memory in the disk itself.
Can you repeat it once again?
So the OS of the computer, the OS, so it's stored in the secondary memory itself, right? So that it doesn't get erased every time we turn off the computer.
Correct.
Yeah. Okay.
So once the system is switched on, then the kernel of the operating system, a subset of the operating system files, moved from the hard disk into the main memory. Okay, so that is called booting. So when you switch on the system, OS gets loaded using a bootstrap loader. The kernel of OS moves from hard disk into the main memory, and then it stays in the main memory. Upon requirement, be it a creation of a process or a memory management or a file management, appropriate modules are invoked. So some portion of OS is always residing inside the main memory as long as system is on.
Okay.
And based on need, you call the other routines from secondary memory into main memory. So the OS code will expand and shrink inside your main memory.
Okay, sir. Thank you. So the last question I have, sir, actually yesterday I saw one D-Link router. So the router we have now in colleges we use routers. Sir,
Yes.
so yeah, so I seen the IT guy who was handling the router. So he actually connected the LAN cable with his computer, and then with the help of gateway servers, we have the IP address of gateway, so that we can interact with the interface of the router.
Yes. Can I know what is the doubt then?
Yeah, sir. So, sir, I was wondering, sir, sir, how did that works? I mean, in a classical computer, we know that everything is there's this processor which executes and do everything for us. But in a router, is there any processor that works like that?
Okay. So this topic is outside the purview of the subject, but since you asked, I can tell. The router also has a small processing component. It has a small microcontroller inside that. And based upon the packets that is been coming, there is a table lookup. And based on table lookup, the packets are being forwarded into different output links. So it has a small processor kind of a work that is been there. And it can be connected. And there are some special commands. So when I give some command, what it does is it goes to the internals of the router, and then the contents of certain storages or tables is being retrieved back. So using external commands, I can configure, I can read the value, I can write the value of certain buffers of the router. So that is something that is called as an interface to the router. So I can have command line arguments that I can give from a computer through the LAN port. Upon receiving this command, certain values are read or read. And then the interface will try to understand what is the value that has been read and displayed in a meaningful format for a user to understand. So these are all called software configurable routers.
Okay, sir. Yeah. Thank you, sir.
Okay. So there is a question from Samuel. Samuel, can you please then unmute and speak if you are there?
Hi, sir.
Yes.
I'm from Bangalore, and I'm currently working in service industry, sir. I mean, VLSI from a service company.
Okay.
I want to get into some AMD or any like product company. For that, I'm doing the certification.
Okay.
And then in one of your earlier video, in the first introductory video, you told that you'll be giving letter of recommendations.
Yeah.
Is it possible?
Yeah. So Samuel, it's good that you would like to work with us. So if you wanted to work, especially you told about an NOC, there are some architectural simulators that has been available. One of the simulator where our lab has expertise is called Gem5. It can model the cache memory, it can model the processor and the interconnects. So it is an architectural cycle accurate tool, an event-based cycle accurate tool where you get to know or you can configure many of the system parameters and see specific quantitative metrics like throughput, like IPC, like cache latency, miss rate, hit rate, everything that you can get. You can make modifications on the design based upon the optimizations that we learned, and then you can also assess these quantitative metrics. So these simulators will help you to get a hands-on experience on how to work with the computer designs. So that is one side of getting an expertise. The second side is whenever you work in hardware, you may have to write code in hardware description language like Verilog, VHDL or BlueSpec, synthesize the code, and then try to see what is the design, what is the overhead of the design, how many cycles it will take, area and power and other aspect. So these are the two things. One is the design with the help of architectural tools, which will get you a cycle accurate value. And then how much is one cycle? What is the area and power consumption using hardware synthesis, HDLs. These are the two ways in which you get an expertise. So if you are then interested in working with our group, you can write to us. You can write to Rajeshwari. She will be able to coordinate with you and to give some inputs on some of the practical work examples.
Sure, sir. Thank you so much. And even I tried, it's like one professor is there, sir, Oner Mutlu. I tried to, before coming to you, I tried to follow his lectures. Even he has a simulator, but I could not make it. I mean, I could not understand. I don't know how to get into the system and all, because it's all just YouTube lectures. And thank you, sir, for this opportunity.
Yeah, Professor Onur Mutlu is considered to be one of the pioneer computer architect. I also learned from him a lot. So his videos are at least 10 times of better quality than mine. So following Professor Onur Mutlu's lecture will give you a deeper understanding of the subject. But of course,
Yes,
if
sir.
you wanted to work with some lab tools, some architectural tools, whatever I told will help you.
Sure. Thank you so much, sir. Thank you.
So any other question?
Yes, sir. So the above shared screenshot.
Yeah.
Uh, just a second. Yeah. So the latest screenshot which is shared, directory protocol.
Okay.
In this directory storage per node, 200 MB, and there's the calculation. 200 is 25 times 8, and then 2 and MB is 2 power 20, and then it becomes 25 times 2 power 26. So like I wanted to know that how that happens.
So see what happens is 25 is there, that 8 becomes 2 power 3. Okay. So that is because 25 into 2 power 23 bytes. And 1
Yes,
byte
sir.
is 8 bit. So 25 into 2 power 26 bits.
Okay, sir.
That byte I converted to bits. That's all. If you can see that,
Yeah.
it's bits.
Okay. Sorry, sir. It was a silly one.
Yeah, it's okay. No problem.
Sir, in assignment 8, problem 7, it's like written that P2 processor will forward its modified data to P1, right? But it's using Messi protocol, and I think Messi protocol can't forward the data, so I think it wouldn't be able to share its data to
Let me
P1.
first hear. Rajeshwari, is assignment 8's date over? Submission date?
Sir, I need to check 1 second.
Yes, sir, it has been graded.
It's been graded?
Yes.
Okay, so let me take assignment 8. Assignment 8, which question?
Question 7.
Consider a messy cache coherence protocol. The cache controller of processor P2 snooping on the bus receives a broadcast that processor P1 encountered a write miss on a cache block B that is in M state in P2. Apart from forwarding the copy of B to P1, what will happen to the state of B on P2?
Yeah, but it's using Messi protocol, so I think the modified data would go to memory first, and then it would retrieve from memory, right? In Mossy, you could have send one data if you have modified it to other processor.
So what happens apart from forwarding a copy of B to P1? What will happen to the state of B? So the state of B happens is the moment somebody else is going to perform a write operation, the state will go to invalid state, right?
Yeah.
Then I cannot write on it.
My just doubt is, can we send modified data from in a Messi protocol to other processor without updating it?
No. It all depends on whether it's a cache update protocol or a cache invalidate protocol.
Yeah. So I think it won't be able to send it to P1, right?
See, what happens, a cache controller of processor P2 snooping on the bus receives a broadcast that processor P1 encountered a write miss. So P2 already has the updated copy, and then someone else is going to perform a write on it. So what I am asking is, what will happen to the state of B? That is, the question is limited to that. What is with respect to the state change? So someone is getting, so the P1 is getting the latest copy of B. What it happens is become an invalidate, it write to the memory, and from memory it is going to get into the copy. The latest copy P1 will get. But what will happen to P2? P2 was already in the modified state. Now since someone else is going to write, I cannot keep my state like that. I have to go to invalidate state.
Okay, sir. Understood. The word which was used was forward, so I thought it would send directly, but yeah, I understood.
Okay. So I am telling, apart from forwarding the copy of B to P1, I'm not telling who is forwarding.
Okay.
So P1 gets the data from somewhere, and then essentially my question boils down to what happened to P2.
Yes, sir. Okay.
Okay. So there is a question from Sudipta which is telling, is it possible to have a non-volatile cache? Will it make access time even faster? So Sudipta, yes, there is something called NVM, non-volatile memory is there. The new STT RAM, okay, ferroelectric RAM. But the problem is they have something called endurance. There is a maximum limit at which I can write on it. So let's say after 10 power 9 writes or 10 power 10 writes, then the memory is no longer available. No longer available for read and write. So the lifetime is less. So L1 caches we generally don't use for NVM, but there are a lot many techniques wherein your L2 and last level caches can be NVM caches. Even, but the problem is the NVM is slower than your SRAM. So NVM is not a suitable choice for L1 cache, but it can be a suitable choice for last level cache or hybrid caches. So to Bharadwaj already mentioned that in the chat box. The NVM access time is larger than that of your SRAM, which is conventional volatile memory. So NVM has a good property of it has good packaging features, but it is slower. Any other question? Did we miss anything? So there is a question from Anirudh. In an era AI, what is the role of CPUs besides data processing task of GPU? What is the latest research and optimization done in CPU architecture for AI? So Anirudh, if you try to understand, all applications are not AI. There are still some scientific applications that works on a conventional program. Let's say you take an enterprise application, a billing software. So these are all conventional sequential programs. There may be some programs which are based upon neural networks, which require specialized hardware. So we have something called neural network architectures. We have some topic on it, domain-specific accelerators towards the last week. So what we do here is we are going to have some extra hardware components which will help in performing AI tasks. Typically what happens in a neuron is you have multiplication of inputs and weights. So this multiplication of inputs and weights, you require multipliers. So the conventional AI processors will have, rather than one or two multipliers, it may have hundreds of multipliers. And you have a mechanism which will transfer your inputs and weights into these multipliers. So that becomes the activity done by a neuron can be speeded up. And that's exactly what your GPUs does. So we cannot write off CPUs because CPUs are essentially required in order to fetch the data, store the data, and your conventional instruction set architecture required only for single input multiple data stream. Whenever there is a data level parallelism, then only GPUs can be of use. So don't get me under the assumption that we have only AI related programs. And how can you do that? For AI programs, there are not much of branches. It is all compute intensive. I have to do a same set of operation on a large set of data. So their branch predictions will not help because I don't have branch. Load store unit may help because I have to move my inputs and weights. So having more load store unit is helpful, but branch prediction is not helpful because essentially your AI programs are not control dependent programs. It is a sequentially connected programs. I hope I answered an Anirudh's query. If Anirudh has anything more, then please open and speak up. Any other question?
Sir, I have a question regarding the exam point of view.
Yeah.
Yeah, so basically while solving the weekend assignments, I felt like there is a need for a calculator because I'm getting a values in the decimal points.
Yeah.
So in the exam, do I need to carry my calculator?
No, you are not allowed to use a calculator. You will have a virtual calculator on the screen.
Okay.
You can make use of those calculators for numerical problem solving. Okay.
And also, sir, like, is it possible for us to solve whatever the paper you are setting at the IITs? I mean, just for practice.
Okay, we can share a few questions, but then we have not set up anything difficult. Whatever we have asked during assignments, the same difficulty level only is being put for final exam as well.
Okay.
So the QP is not an IIT level QP except maybe one question or something which is of slightly higher level. But all other questions are of the same difficulty. I think in all the assignments, towards the end, you may get one or two questions which are of slightly difficulty level higher than the initial questions. Right?
Okay. Yeah.
So similar to that, you can then expect the same kind of questions. I have not made it hard.
All right, sir.
So Sumuk is asking question, what about ReRAM? The same problem. Whatever, many of the non-volatile memory has this problem of endurance. And then access time. So even ReRAM has the access time problem, which is slower than SRAM. Yes, Shubham, you wanted to speak? Your hands is raised.
Am I audible?
Yes.
Yeah. Good evening, sir. So I had a question of like all these concepts that we are using to optimize on the cache and all, like coherence and the other processes in the previous week. So all this is handled by the microarchitecture nearby the hardware, or it is some code written in the memory so that it can be swiftly passed on from the main memory to the cache and blocked, means on the parallel it is blocked on the other caches. So how is all these dynamics handled?
So Shubham, you have to understand anything that moves to the code, then it can be handled only at the OS level. So whatever optimizations that we learned over the last week, these are all implemented by small control circuitry, be it early restart, be it the critical word first bringing or pipeline to fashion. Everything is a control circuitry. There is no hardware involved in it. Did I answer the question? Is that what you asked? Optimizations are done by hardware or by software. That's what you asked, right?
Yes. That is exactly
completely hardware. There is no software involved in this.
Yeah. Okay. So these are like some lines which will get high, low as per the board hardware, which will finally
that is
as per
working
that.
at the nanosecond level. The moment you go to writing a program whose execution result in the optimization perform, it becomes at least 1,000 or 10,000 times slower.
Okay. Yeah. Okay.
The moment you let's say you write 10 lines of code whose execution will perform a cache memory operation. Then it involves somebody has to fetch, somebody has to decode and execute. So program-based execution, any activity that you do based upon some set of instruction, which will take milliseconds. The moment you do the same activity by some logic gates whose output takes care of an action, then it will be at the nanosecond level. So that's the advantage of having something implemented in hardware, which will faster than something done in software.
So, okay, all this logic is handling at the hardware level for us.
Level. It's a collection of logic gates, some combinational circuits.
Yes. Okay. Yes, sir. Clear.
So to make it more clear, maybe I'll tell you, I hope you know about artificial neural networks where you have a collection of neurons. Okay, I can write a software program which will mimic or which do your neural network. But ultimately, some input into weight is being multiplied. You require a multiplier at the hardware in order to perform xi into wi. Okay. So when you have only, let's say 10 multipliers, all what you can do is, even though you have 10,000s of multiplication to be done inside a for loop by multiplying two matrices, ultimately it will be very slow once I do it in hardware because you have only 10 resources wherein you can multiply. So I can do the same neural network operation if I have 1,000 multipliers, then that will be at least 1,000 times faster than writing a piece of code and make use of 10 multipliers to carry it out. So the more hardware, the more operations done on hardware, it will be very fast.
Regarding this, I was like, usually when we implement something for our usage, for our project, so that gets verified. So if I am coming up with certain implementation which will be useful for my project, how do we debug all these systems like at the hardware level if I go? So for this kind of verification, how do we ensure that it is doing it correctly, and it's not my software which is at the fault.
No, can you tell me the question at once again? You're asking about how the hardware does it without any error. Is that what you asked?
Yeah.
Oh.
Or is there any, if there is any fault, how do I debug all that?
No, that's a problem. See, at the time of the design time itself, there is a process called digital design verification, where you make sure. So once you make sure this particular circuit is functionally working correct, then only I transfer the design into the layout and then fabrication. Okay, so we have something called verification, which is done before the fabrication, and after fabrication, we have something called testing, which ensures that every subcomponent of your chip is doing its intended task. So if there are any mistakes that is still not recovered during a verification and testing time, the bug stays there, and that's exactly what is your hardware bug. So every design goes to an extensive verification, which makes sure each circuit is doing intended what it is supposed to, and it is not doing anything which is not supposed to. One, it happens before fabrication, that is called digital design verification. That itself is a separate stream of VLSI and architecture. And the other one is post fabrication, that is called digital design testing.
It's like this tools we use, jump file and the other simulation tools. These tools are actually used for doing all these design processes and design verification.
No, these tools are only used to understand what happens in a microarchitecture level. Let us say I wanted to know the number of cache misses when you run a program. Okay, without fabrication, how do you do? So you need some programming model, some tool, some mimic, something that mimics the real hardware. That is called a simulator. So I can run a program. You don't have a processor, you don't have a cache memory, but you have a set of programs, a collection of programs which mimics the operation of your cache memory and processor. And I can run an application. I can see how many cache misses you have. I can see how many compulsory misses you have. That is called a simulator, something which will mimic. So before fabrication, I get an idea of given, or if I fabricate such a kind of a chip, what are going to be my numbers, performance numbers in terms of IPC, numbers of stalls, miss penalty, everything. So then I know, okay, this design is good. Now I need to write a hardware description language using Verilog about the design change that you wanted to make, synthesize, and then do the fabrication. So prior to fabrication, you do digital design verification. That verification is done on a synthesized code. There is no connection for any GIM5 or any architectural tool there.
Thank you.
Okay. So Chirag?
Yes, sir. Sir, so there I was like researching and all. So there's a concept 3D cache. Can you talk about it a little?
3D?
3D cache, like it's.
Yeah. See, this is not about 3D cache. It's about 3D memories. So typically our memories are two-dimensional. Okay. And then we have one more layer, row, column, and the thickness, the vertical layers. So when you have a layer of memory that is being stacked, we call it as 3D stacked memory.
Okay, sir,
So,
understood.
and then there comes with more heat management tools, because the innermost layers would be very much hot and the layers that are closer to the processor would be hot. So we call it as 3D stacked memories. So it's a memory technique wherein I need to have more packaging density, because when I cannot increase the area, I am thinking in volume perspective, but it is coming with its own challenges like thermal management, the power management of it, and how do you access, how do you remove the data. So 3D stacked memory is the new way in which I can have more compact memory in limited space.
Okay, sir, understood.
So, Bharadwaj, would you like to speak up regarding the query that you put in Thomas Solo's algorithm and design? Please unmute and speak.
Hello, sir.
Yeah.
Yes, in Tomasulo algorithm, we have these reservation stations, reorder buffer. So can we design all these in using Verilog and finally
Yes.
implement this on FPGA.
This is the way how we do.
So this is how the research work goes on.
Yes, this Thomas Solow algorithm implementation is not that easy. It's one of the heart of the system. So ultimately, you have to write a Verilog code for Thomas Solow's algorithm and get it done in FPGA. If you really wanted to do that. Okay. So the research in architecture is done in two ways. Are you looking from a performance viewpoint where you work on architectural tools and simulators? That's what I told, Gem5 or Sniper or some tools where you are most bothered about improving the functionality. Now, what is the cost of adding a new functionality to an existing design? Let's say my cache behaves like this. C, I wanted to change or I wanted to bring some optimizations. So I come up with another design called C dash. So C and C dash will vary only in few extra control circuitry. So the design of C is already available in Verilog. You wanted to add up the new extra resources, and then you use EDA tools like Cadence or Synopsys, which is you get to know, okay, how much extra power or extra area this C dash is going to consume compared to this. So if it fits into your overall power and energy budgets and area budget, C to C dash, I get savings in IPC or cache miss penalty this much at the expense of this much area and power.
Okay, sir.
Yes, Chirag.
Sir, so in order to follow the current research and all, what is the requirement to understand? Like, do we have to study CMOS and other topics for?
No. To understand what is happening in architecture domain, you need not even go deeper into the electronics. Okay. With computer architecture codes like this, you will be able to follow research that is published. So I will just type the conference name. These are all conferences which you can refer. Okay, so these are some of the conference names that we have touched, and then these are all talking about changes in processor, changes in cache, changes in interconnects. So International Symposium on Computer Architecture, High Performance Computer Architecture, all these, only architecture knowledge background required. But whereas if you go to, let's say, DAC, DATE, then the ICCAD, VLSI design, this has architecture component as well as digital design verification, testing, EDA tools. This also would be available. So first is pure architecture conferences. Second one is architecture, VLSI, embedded testing, verification track also would be there. So one of the premier conferences in our country that is happening is VLSI design. It happens every year in first and second week of January. It's a 5-day program with 2-day tutorials. So VLSI design 2025 is happening at Bangalore. You can search for it. It's one of the area where computer architecture and VLSI people generally meet. They give liberal fellowships for students to travel. You can look into this conference website. Rajeshwari or Vivekananda, can you please post the VLSI design website URL such that if anybody wanted to know what is happening, you can attend these programs. For students, we call something called fellowships. You can even attend, you can even apply for fellowship. Fellowship means they will give you travel and free registration and accommodation. So you can get to know the VLSI design website. So if you are not getting fellowship also, it's only 5,000 rupees. That is the payment. It's a very good experience. Lot many industries will come with your background. You will be in a position to learn and appreciate what has been happening. Any other query? Okay. So if there are no queries, I'm just summarizing. Please do study well for the exam. We may have one more live session before the final exam. Go through the assignments carefully, redo the assignments once again, and that will give you a complete upper hand. Go through the tutorial videos specifically, and this will really help you. And then I look forward for some of the toppers to join us for potential MTech or PhD programs. We do have the internships in the next summer for those who are really scoring well. So wish you all the best for those preparations. And I'm hoping that, and even some of the students then replied back telling that they had some internships and then it was the learning from architecture course was really helpful for some of them in getting these internships. So these are all good feedbacks for us as teachers also that this course is value adding in their placement and internship probabilities. Yes, Shubham, you have raised your hands. Please ask your query.
Hello.
I can hear you. Shubham, please repeat once again.
Yeah, sir. One last question before closing this is, I have worked on microcontrollers, and then there are some projects which use FPGA also. So FPGA has got a much more faster processing and parallel computing capabilities also. So what goes lower than that, like as earlier one person asked regarding the FPGA design and all. So what goes more below that it is implemented in our multi-core or this optimizing design and all?
It is ASIC, application specific integrated circuit. So FPGA is reprogrammable, whereas then ASIC, once you do it, that's fixed. So FPGA is all about, I have a device where I wanted to put some design. Okay, and then I verify everything is working. I wanted to redo a different design. So FPGA is more flexible, whereas ASIC, the flexibility is lost.
Okay, so which means that usually in FPGA also we can flash it, reflash it, our code by modifying, but in ASIC we can't do all that.
No.
Okay. Yes, sir. Got it. Thank you.
There is a question from Bharatwaj. Could you suggest US universities for computer architecture masters? So Californian University, University of California at San Diego, at Irvine. So many of the Western US universities, they are good. Carnegie Mellon University is good. Georgia Tech is good. Then Stanford is good. Then University of Florida, it has a good computer architecture group that's there. Colorado State University is good. Washington State University, it's good. University of Pittsburgh. These are places where if you typically see. To Bharadwaj, my answer is you look into the conferences that I listed, ISCA, HPCA, Micro, DAG, DATE and all. Look into potential authors. So these are all places where top computer architects publish. So look into those places and then from the affiliation of the authors, you would be in a position to get to know from where are they coming from. These are the top universities. So getting a paper in ISCA or HPCA, it's not that easy. So if they are consistently publishing in these conferences, they have a very good computer architecture group. Hopefully I answered that. So if there are no other questions, we are going to wind up today's live session. Thank you once again for all of you who have joined. Continue learning the rest of this course and never lose hope that the exams are coming and don't get yourself stressed. At the end of the day, go through all the assignments very well. If you have done the assignment by yourself, or even if you have not done the assignment by yourself, but if you know how to solve them, then that will really help you. 60% of mark is guaranteed if you know all the assignment questions very well. Okay, so go through the videos once again for quick recall and then wishing you all the best. Thank you. See you after a month in October for the next live session.
Thank you, sir.
We can complete the meeting.
Thank you, sir.
Thank you, sir.